Hello everyone, I am Jason Jim, a backend developer. Today I want to share a special experience about how I unified 9 years of scattered knowledge using AI. I will tell you about building a real-world RAG chatbot using OpenAI and LangGraph. Let me introduce myself briefly. I currently manage large-scale payment systems. My main job is integrating dozens of PG components and managing complex payment architecture. Today, I will share how I use the AI to solve the problems caused by this complex domain knowledge. Here is the agenda. First, I will explain why I started this project. Second, I will share the challenges and solutions. This is the key part. Finally, I will show you the system architecture and a live demo. Developers, the speed of AI growth is scary, isn't it? At first, I felt anxious. I thought, can I survive if I stay still? But realistically, I cannot become an AI researcher overnight. So, I set a new direction. I will not just study AI, I will be a developer who uses AI to create real value. So, what problem did I want to solve? I faced two big pains: complex payment domain and scattered knowledge. Every PG company had different policies. This knowledge was scattered in documents, source code, and colleagues had. When a colleague left, the knowledge was lost. I had to answer the same questions over and over again. It was very inefficient. So I made a decision. Let's systematize this knowledge. My goal was to gather 9 years of policy knowledge into one place. I wanted a system where even a new hire could you ask AI and find the answer instantly. Technically, I wanted to verify the best combination of OpenAI and Korea embedding models. To solve this, I chose RAG. The process is simple. First, chunking. We split documents into small pieces. Second, embedding. We convert them into vectors and save them in a DB. Third, retrieval. When a question comes, we find the most similar document. Finally, generation. We ask the LLM to answer based on that document. This prevents hallucination and provides accurate information. Let's see an example. If I ask, what is company A's policy? The vector DB finds the company A policy guide. Then GPT-4o-mini analyzes the document and gives the correct answer. For the tech stack, I focused on practicality and scalability. For the UI, I used Streamlit for quick prototyping. For the LLM, I chose OpenAI GPT-4o-mini for code efficiency. For embedding, I used a Korean optimized model from Hugging Face. Finally, For orchestration, I used the LangGraph to expand it into an AI agent later. Now, theory is over. Let me share my real development journey. Like everyone else, I started with the tutorials. I thought, wow, this is easy. But that was a huge mistake. When I applied real data, it failed. The AI gave wrong answer or cut off sentence. I realized tutorials are different from production. The biggest problem was it couldn't find the information. For example, I asked list all the PG providers we support. We have 30 providers, but the AI said we have A, B, and others. This was useless. Turning parameters didn't help. The root cause was the data. Traditional manuals are scattered. Mechanical chunking breaks the context. So I completely rebuilt the document into an FAQ format. I filled the question and answer together, so the context is never lost. My strategy was one FAQ equals one chunk. Please look at the code on the screen. I used the metadata for filtering, and I embedded the full Q&A set as on block. The result was dramatic. I didn't change the algorithm code at all. I only changed the data structure, but accuracy went up to almost 100%. Garbage in, garbage out is true. To improve accuracy, I added metadata filtering. Common words like payments appear everywhere. This, this confuses the search, so I force users to select a category. This physically narrows the search scope. I also introduced hybrid search. AI understands meaning but fails at specific keywords like IDs. So I combined keyword search and vector search. I used the 40 to 60 ratio. Now it catches both. Here is a surprising discovery. The performance difference between vector-only and hybrid is small. Why? Because my FAQ data structure was already perfect. This taught me data design is more important than algorithm. This is the final system architecture. The user asks a question and the LangGraph pipeline runs. In LangGraph, I clearly separated retrieval and generation. This makes debugging easy. If an error occurs, I know exactly where it happened. I also used streaming for a real-time experience. This is the actual Python code using state graph. I will share this code after the presentation, so you can run it yourself. Now, let's watch the live demo. What's next? I plan to connect this with our backoffice API. My ultimate goal is an AI agent. Imagine an ops team member asks, "Why did order 1, 2, 3, 4, 5 fail?" The AI agent will check the logs and say, "It failed due to insufficient funds." This will free our team from repetitive tasks. That concludes my presentation. I have open sourced all the code on GitHub. I hope this inspires your work. Thank you.